Welcome to the training on the Beta Streamflow Duration Assessment Methods for the Northeast and Southeast. Our presenters today will be Brian Topping, Ken Fritz, Amy James, Christina Nichols, and myself, Rachel Furtick-Edgerton. Next slide. So we're going to start out with a brief background on streams and SDAMs and a description of beta SDAMs for the Northeast and Southeast, followed by some key considerations when conducting these SDAMs. Then we will walk through the data collection procedures, including desktop recon and how to measure each of the indicators. After that will be a section on data interpretation, the web application, and where to go when more information is desired. Next slide. In this first section, I will cover some streamflow characteristics, followed by a general introduction to streamflow duration assessment methods and their uses. And I'll finish with a brief overview of the three streamflow duration classes and a little about the development and description of the beta SDAMs for the Northeast and Southeast. Next slide. So streamflow is defined simply as the movement of water in a confined channel. Streamflow is different from standing surface water, subsurface flow, hyporheic flow, or seepage. And also, we're talking strictly about freshwater systems, so it's not the movement of water in a tidal channel. Next slide. There are many characteristics of streamflow that ecologists and hydrologists focus on, things like magnitude of flows or the timing of flows. We're really focused on the duration of streamflow, and this is one of the most important aspects in terms of what it means for ecology and ecosystem functions, and it has a lot of management relevance, as many of you already understand. Next slide. Streamflow exists on a continuum of wetter streams to drier streams. As with many things in the natural world that are on a continuum, there's a lot of complexity. So we have to simplify things to create a classification system in order to study and manage them. We impose classifications on the streamflow continuum, but there are a lot of gray areas in between. One of the most widely used classification systems for streamflow used by researchers and in the management community are the terms perennial, intermittent, and ephemeral, which we're going to talk about next. It's useful to point out that there are a lot of different ways to characterize how streams differ from each other in terms of streamflow. You can talk about number of days of flow, you can talk about the predictability of when that flow occurs, or the timing of that flow. Next slide. Streamflow duration is itself dictated by changes in the water entering or exiting the reach. The inputs come from discharge upstream as well as discharge from groundwater, direct rainfall, or runoff from surrounding upland. So all these things add water to the reach. Water leaves the reach by flowing downstream, percolating into groundwater or evaporating, either mediated by plants or just through temperature. The balance of inputs and outputs determines whether you have streamflow present. In ephemeral streams in general, the outputs are stronger than the inputs, whereas the opposite is true in perennial reaches. And with intermittent streams, it depends on the time of year and stormwater events, which are the ones that are more dominant. Next slide. So, what is an SDAM, or a stream flow duration assessment method? The definition we use is a rapid field-based method of classifying the flow duration of a stream's reach. Field-based, meaning that we're talking about indicators that we observe in the field. These are distinct from hydrologic models, which are another tool that can help managers understand stream flow duration. Please mute yourself, please, if you haven't already. Thanks. And they're rapid, meaning that they can be completed in a single site visit. So you don't have to conduct long-term data collection in order to use them. Next slide. So an indicator is an easy to measure property or an ecosystem that tells you something about a hard to measure property. So the hard to measure property is streamflow duration. The easy to measure things may include geomorphological characteristics, hydrology, biological characteristics and geospatial measures as well, things like climate. An indicator for stream flow duration can be a control on stream flow duration. You're measuring something that actually dictates how much water is in the creek or how much water can leave the creek. So for example, streambed substrate composition can tell you something about percolation to groundwater. It can reflect responses to stream flow duration, things like biological organisms adapted to certain flows, like hydrophytic plants. There's also a third category that we don't discuss as much, and these are factors that are associated with stream flow duration. They're not controls or responses. So a good example might be sinuosity, where you have more sinuosity with more flows, even though it's not directly governed by that. In general, we prefer indicators that reflect long-term conditions over those that are more transient or reflect only recent conditions, which is why our SDAMs often feature things like biological indicators over things like the presence of water. Next slide. So as I mentioned, stream flow duration is one of the most ecologically important characteristics of a stream. And because of that, it underpins a lot of our regulatory and management decisions. Notably, it helps us determine whether it will receive protections under the Clean Water Act, its jurisdictional status as a Water of the US, or WOTUS. The problem is that to really understand stream flow duration, you need long-term hydrologic data, and we are typically only collecting at small numbers of sites, like where there are USGS stream gauges. So we don't often have the information where we're making our management decisions or policy determinations. So having a rapid field-based SDAM will help us have the information we need to make the right decision for those streams. Next slide. So to be clear, an SDAM by itself is not the same thing as a jurisdictional determination or a JD. JDs are based on current regulatory guidance and policy, which may change to reflect a different administration's priorities or evolving case law. JDs for certain aquatic resources require timely stream flow duration information, and that is what SDAMs are intended to provide. You can't make a jurisdictional determination solely based on an SDAM. You need to consider a number of other factors, so it's only part of that determination. And lastly, SDAMs, of course, have a number of other management and research applications unrelated to jurisdictional determination, unrelated to Clean Water Act jurisdiction. So you can use them, for example, to set restoration goals or to assess water quality. Next slide. So on the same note, an SDAM can't tell you what the historic streamflow conditions used to be. They are only going to tell you about present day, or at least recent conditions. So for example, a stream that was historically ephemeral, but now has perhaps treated effluent sustaining perennial flows will come up as a perennial stream. Next slide. We designed this SDAM to classify regions into 3 categories. Those classes are perennial, intermittent, and ephemeral. The photos show some really beautiful forested streams as examples of those categories. Next slide. As I mentioned earlier, perennial streams have inputs that are greater than outputs of water in the reach, and they contain flowing water throughout a normal year, and they typically have the stream bed located below the water table for most of the year. They may occasionally dry, but those are usually only in response to extreme climatic variation. Groundwater typically supplies the base flow for perennial reaches, but there can also be stormwater runoff or snowmelt as well. I'm showing you some data that we collected in Rhode Island as part of the study using what's known as a stick logger, a stream temperature intermittence and conductivity logger. And basically this logger tells us when water is present. The plot shows the variation in stream flow from January to December 21. The blue areas above the yellow calibration line indicate stream flow is occurring. So you can see that while the discharge can vary quite a bit during that period, it never goes dry. Next slide. Intermittent streams are channels that have flow for only part of the year, typically during the wet season, and the stream bed is below the water table, or you have snowmelt sustaining it from surrounding uplands. They typically do have groundwater influence, but the flow varies greatly with stormwater runoff. This plot of stick data taken in Ohio shows the variation in stream flow from the same period, from January to December 21. So you can see how this looks different from the prior graph. Quite a bit of variation in flow from January through roughly April during the wet season, and then generally a dry period punctuated by flow from storm events. Next slide. Finally, there are ephemeral streams. They only flow in direct response to precipitation. They typically flow for short periods and typically only during and shortly after large precipitation events. The stream bed is always above the water table, and stormwater runoff is the primary water source. This plot of stick data from Florida shows the period between March of 21 and February of 22. Since we know that only the blue areas above the yellow calibration line indicate flow, that tells us it was dry for almost the entire period, with only a few brief periods of flow in response to precipitation events. So we classify this reach as ephemeral. Next slide. The beta SDEMs for the Northeast and for the Southeast distinguish flow duration classes of stream reaches as defined in the paper you can see cited here by Wall et al., which is based largely on vegetation type and precipitation levels. In the Northeast, snowmelt contributes some flow to streams and rivers during the year, while the Southeast is dominated by rainfall runoff other than snowmelt, including tropical storms and hurricanes. The beta SDEMs for the Northeast and for the Southeast are adjoining the Great Plains method, for which the beta method was just released in September of last year. While both the Northeast and Southeast beta methods are described in the same user manual, they are separate methods with some overlapping indicators, which you're going to hear about in greater detail next. And with that, I'm going to hand it over to Brian.